Hello, everyone. My name is Jeff, and I'm going to get to walk through another fun end of class project with y'all. This time it's for course two, the second course in the series. And this one was managing machine learning projects through Duke University. Now, for the project, we were basically given an opportunity to apply the knowledge that we learned during the course. And in this one in particular, the course was through a frame out of a machine learning application project. So basically managing what these type of projects are. So as a part of that, we get to choose a project topic, work through a series of steps as dictated through the course, and evaluate the opportunity. Walk through the business understanding phase, basically the CRISP DM process for it, and develop a validation plan for the solution that I come up with, and then consider some key system design decisions for the model. And then finally, try to identify some potential issues that may affect the final model once we get it into production. And I actually have an additional extra step that I did just for fun, because this is very relevant to what I've done for a long time, 18 plus years, and we'll get into that here in a little bit. Okay, so the first step is to identify, is there a problem? Yes. Speaking from experience, as I mentioned before, especially when I was head of the PMO, we always get asked on the fly, oftentimes, in terms of resources, to constantly juggle the staffing across multiple projects and for the different business units and portfolios. And then we have to keep, of course, some of the business aspects of it in line as well. We need to help answer those type of questions. It's not just simply, do we have enough people? It's a little more in depth than that, right? So I'm going to throw that in here as a part of my project, because that's what we tend to be expected to do. The famous question, can we take on more projects? Yes, that is one of the questions, but that's not all of them that I want to try to answer with the project. We also have to take into account utilization factors and actual capacity. However, most of the things that we use today are kind of static and after the fact, so they're not always the best. And we tend to have to react to that. What I want the goal of this to be is to be a little more proactive, right? Some of the business stuff that I'm going to try to address is actually keep in mind profit margin or gross margin erosion, excuse me, the actual target dates if we miss those project deadlines, and see if we can incorporate that. So that's how I'm going to frame this in terms of the project. Why it's attractive to me. Number one, like I said, it's been a part of my work life quite a bit. There's lots of tools out there, Jira, NetSuite, that already capture hours that we log time in. And we can capture project timelines and those assignments and who's doing what in terms of the resources. So the pool of data is already there, right? It's just available. So can we do it? Yeah, sure. And we'll walk through that here in terms of the model itself. In terms of picking a goal for it and business impact, I think even if we can get a 5 to 10% improvement in achieving some of these things, that's how we're going to define success here. If we get our margins protected, we're actually predicting when we're running up against deadlines, or we are over allocated or are under allocated in terms of resources assigned, then that'll give leadership a level of comfort and confidence, and be very useful, especially in our world. So to continue the definition and description of the opportunity, can a model help? So in order to help determine that, I looked at the current ecosystem of different tools out there, some things that I have used, some that I haven't, and did some research. And you can see the list there. Basically, as you go through the notes and limitations, what is really missing there is the intelligence layer, right? None of these tools are proactive, and that's what we want it to be, and can't forecast proactively or predict when a team might miss a deadline. Even more importantly to the business, if we're going to be crossing a margin threshold on a project, especially if it's a very large one. If they they basically don't predict the future, and that's what we're looking to solve here. So leadership, people like myself and so forth, can actually take action earlier and protect those type of things and outcomes before they actually happen. Now, to continue that, is anybody going to care about this other than myself? Yeah. So, in other words, are people actually going to care about this? Um, Short answer seems to be yes. Again, I did a bunch of research, as you can see here, with the sources. 80% say workforce planning is critical and that we need better technology. The biggest thing in my research that jumped out to me was from Gartner's research in 2024, in which it stated most of the resource management platforms today focus on scheduling rather than predictive forecasting, and that's the goal here. So the market is mature in tooling, but immature in intelligence. And as I stated earlier, that's what we're going to look to address with this. Okay, so to continue following the CRISP DM process, the first part is business understanding. So the goal is to forecast resource over or under allocation before it impacts any timelines or profit margins, right? That's how we're going to define the problem. Defining success, we'll be able to see the different outcome and output metrics there as they're listed. Those are basically just some conservative numbers that I went with. It would be great if we could actually get the data and see how much we do with these goals. Maybe we'll do that later in the course. That would really be fun, and have an actual model. But basically, our definition of success is, can we reliably see, at a minimum, 1 to 2 weeks ahead of time, which projects are approaching red thresholds? And I've got those thresholds defined here in a later slide for you to see. Okay, so step 1.3 of the process, I mentioned those thresholds, right? So those are listed there. Now, these are thresholds I'm proposing for the model to use and for this particular project. These are types that I've actually used at work. So along with the data sources and features for the model, we want to look at, obviously, to incorporate in it billable, non-billable hours, project information, of course, from the source, Jira, NetSuite, dates, tasks, milestones. But we also want to take into account capacity data for a person, for a project, and use that in order to determine velocity, hours logged versus plan, things of that nature that we would normally do on the job anyway. So what we want to figure out is basically how many buffer days until projects are due, do those threshold calculations, and then track across projects the different resource allocations for them, and see if they're hitting any of those marks. But we also want to look at both sides of the coin in terms of risk for utilization. We want to be able to have the model flag when team members are logging less than expected, or they aren't going to meet the target dates, or underutilized as a resource itself, but also when they're trending to over, right? They're reaching burnout levels, or they're being overutilized, and flag both sides of that potential risk. Okay, so this is the solution itself, or my proposed system overview. And as the graphic shows, we have tools out there already as a source layer, right, where the time logging takes place and the project information takes place. So between the source layer and whatever tool that you want to use for the dashboard analytics layer, whether that's Power BI or Tableau, we have this predictive piece, or this intelligence layer. The model would be that intelligence layer, basically sitting on top of the different integrations, right? So we don't have to worry about building that. It'll save a lot of effort in getting to the data itself. So we'll just use those existing APIs and time logs, capture capacity, utilization trends, and then the different buffer thresholds that we've got built in there in that threshold layer in the intelligence layer that I mentioned earlier. And then we'll run those regression-based forecasts. And then we'll send the outputs of that to the analytics layer, whatever that tool of choice is. So the next step in the process is the actual system design. And as we went through it and learned about it in class, we're basically deciding cloud versus edge, offline versus online, and then batch versus online prediction. So these are my actual choices that I picked for this particular project. To meet the goals of the intelligence layer and what I am defining as success, I pick cloud. Our model is going to operate in the cloud from an architecture perspective. All the key project data from Jira or Smartsheet already lives there. So we can easily centralize the processing across multiple portfolios or tools if we have to. The latency would be an acceptable level since the project data would be updating on an hourly basis, right? So we don't need edge devices or anything like that. It'll be running in the cloud. Also allow us to integrate with the analytics layer, right? The Power BI or any other type of executive dashboard in the graphic that we showed earlier. Offline versus online learning. I chose online because we want to update it continuously as new time logs or tasks get received, whether that's daily or hourly. We want to detect early signals, right? Margin slippage, burnout, any upcoming missed deadline because we aren't logging enough hours to hit the target date. We want to actually capture that and see that. We want those patterns to show dynamically across concurrent projects. So those incremental updates keep predictions fresh, whatever the actual cadence is, we would figure that out. But it would definitely be ongoing. Batch versus online. I chose online again. We want those predictions to refresh automatically on a certain cadence or when new data comes in. And that way those dashboards can actually visualize those current project health, green, amber, red thresholds. As I mentioned earlier, as PMOs, we get asked these questions on the fly, oftentimes in meetings without being prepared for it. So having this at the ready is a really big selling point for somebody like me. Oftentimes we require continuous visibility into the book of work. And we can't go back and say, oh, I'd come back to you tomorrow. Delayed reports isn't really the solution that we're looking for here. We want to be proactive, remember. So we want to avoid any missed windows that we should have flagged in the first place. So the next step in the process is the validation plan. So we have to figure things out in terms of the overall life cycle management, right? So we learned several model types in class. And as I mentioned, there might be a better actual model out there, but that's later. A combination of learning models. So what we would start off with is a heuristic baseline, train it to predict the utilization perspective with a linear regression model, right? And then the next step would be a logistic regression or a decision tree model in order to help classify the green, amber, red status. And then we would evaluate that as the data updates, and we would want to focus on MAE, F1, and lead time for that. The validation questions that we would want to ask would be from different stakeholders, right? Different people that would be potentially using this. So does this flag over allocation early enough for basically us to take action, right? That's the first question we want to get feedback on and see if it's actually doing that. Is the data that we're getting help us commit to newer projects faster? That's what an executive is probably going to want to know. And then we want to make sure that it's accurate, right? So we want to compare the model versus the heuristic accuracy in order to make sure we're getting an actual utilization number that's accurate. For the MAE, that's going to be lower is better. we want to know the difference between the predicted utilization percentage and the actual utilization percentage per project, right? And then, so that's how the MAE will be measured. For the F1, what we're going to be doing is we're going to use that in order to be flagged as amber or red, and the precision of those flaggings. So how many were truly at risk? And then the recall, if of the ones that are truly at risk, how many did we successfully flag? And in that situation, higher is definitely going to be better, and the range is from 0 to 1. And then the lead time, the time between when the model first flags the risk and when the issue actually materializes. So less than 16 hours buffer or slip occurs. More days of lead time is obviously going to be better. So people like myself can intervene earlier. Okay, so even once the forecasting model is in production, the work doesn't stop. Now we have to take into account some of the risks and how we're going to monitor it and do the upkeep, right? Maintenance. As we discussed in class, these types of models and systems face risks over time. Certain things like data drift, concept drift, and training serving skew. These can degrade performance very quietly, sometimes without us even noticing. The training serving skew could occur basically if the time entry data isn't processed the same way as the training data. So there's changes on how the resources or the types of work are being coded or recorded. So in order to mitigate, we want to align those pre-processing between training and production pipelines in terms of that data. In order to address data drift, after a new time tracking policy or a tool update, or monitor input distribution, the average hours logged per day, and track the variance against that training baseline. Concept drift is the bigger picture. That's the relationship between the hours logged and the burnout changes, right? We're retrained in order to mitigate that every 30 to 60 days. Latency, delayed dashboard will give us stale signals. So we want to have that updating obviously faster as opposed to more slowly. So at least at an hourly rate, we want to update and keep those forecasts current throughout the day. And then bias and fairness is another one that we want to take into account. It could skew some of the predictions. So we're track in order to mitigate that, the performance by the team and role, and make sure the fairness and consistency across the organization is there. So together, these monitoring steps will help the model stay trustworthy, keep it transparent, and keep it valuable to the business. Okay, now the for fun part that I mentioned earlier. I wasn't sure that the models that we have learned so far are the best fit for this particular solution design. That at least that we've learned so far in class, because they've been very linear or yes or no type of models, classification type things. So I did some research, and then I actually learned about gradient boosted trees. Now this type of model actually sounds like it would be a much better fit, and I actually did a little test run as well. But the way that they work is they're an ensemble of many small decision trees. So basically, if utilization it does a simple prediction. If it's greater than 95% and buffer is less than 16 hours, then it's going to flag it as risk type of thing. Instead of averaging trees like a random forest, what gradient boosting does is it builds them sequentially. So the first tree makes a mistake, then the second tree will actually learn from that mistake, and then the third fixes what the second missed, and so on and so on. So each tree actually boosts the overall performance by focusing on where the last one was wrong. So I thought that sounded pretty applicable and would fit this even better. So the result is a strong, flexible type model that would actually capture the nonlinear pattern. As I mentioned earlier, some of the models we've learned about so far are the opposite of that. in our basically linear models that we've covered so far. So by using this one, we would actually be able to see combinations like a very high utilization percentage plus an upcoming maybe scheduled time off, or we don't have enough buffer time, and it'll flag it as that critical risk. So I wanted to see, how this would actually work. So I actually asked the tool to run a simulation, and it actually used scikit-learn. It had one of the in its library of models to use. It used a gradient boosting classifier on scikit-learn, and it actually came up with some mock data in order to do that. And those are the results that you see there on the slide. Um, the F1 was 0.92 to 0.93. The recall was 0.98 to 0.99. So it caught nearly every at-risk case out of the approximate 400 that it did for the model. So what that means is it was actually very sensitive to risk. So that was a good thing. And the model preferred to raise in amber and red rather than stay silent, which is exactly what I would want it to do from a PMO perspective in order to protect deadlines, resources, and that profit margin, right? Now, the trade-off is that it slightly over predicts the risk, right? So as you can see there, approximately 55 safe items were flagged as risky or were a false positive. In my world, that's an acceptable level. Missing a high-risk project is far worse than investigating a few false alarms. I would rather go investigate than miss a high risk. So the key one, the false negatives, out of 400 risky cases, we only had approximately 6 misses. It said green when it was actually red. That's why the recall score was so high. That's pretty good. So overall, out of 394 risky situations correctly flagged, that's where those two scores came from, the recall and the F1. Both were very good. So thank you. I hope you enjoyed my project and my fun use of a gradient boosted tree model. And have a good rest of your day.